In the last video, I introduced the notion of an argument, and now we're going to talk about kinds of arguments. Arguments are standardly divided into three different kinds based on the different features of the arguments: abductive, inductive, and deductive. Sometimes the word inductive is used to cover both what I'll call inductive and abductive, but we're just going to adopt this kind of three-part distinction. So in an abductive argument, the premises are the relevant evidence, and the conclusion is the best explanation for the premises. So the idea here is that you identify some claims you know are true, and then you try and figure out what would best explain those claims, and you infer that whatever would best explain those claims is true. Now, this is a very common form of inference. It has a presupposition, which is this: that whichever theory best explains relevant evidence is true. I should say this kind of inference is really common in the doctor's office. It's really common in detective stories, but it's also really common in daily life. So if you go into the doctor's office and the doctor asks you what your symptoms are, and you list a set of symptoms, the doctor will try and figure out what the best explanation for those symptoms is, and then infer that you have whatever the best explanation for those symptoms is. If the best explanation is that you ate some bad food, the doctor will infer that you had bad food. If the best explanation is that you have a virus, the doctor will infer that you have a virus. Not that it's guaranteed to be true, but rather that you infer that it's the most probable truth. It's what's most probable. It's probably true. And there's a presupposition here, which is that there's some deep connection between goodness of explanation and truth. So the better an explanation you get, the more likely you are to be true. The more likely the claim at issue is to be true. Now, abductive inference, as I said, is really common in daily life. We're not going to talk a whole lot about it because it's actually quite hard to characterize. It's quite hard to figure out how it works. And correspondingly, the sort of bang for your buck is fairly low. It takes a whole lot of work to start trying to think through how it works. And then you get a little bit of guidance on a kind of reasoning you already do. Next up is inductive inference. In an inductive argument, the premises describe some regularity in the world, and the conclusion generalizes that regularity. This is the kind of inference that you do in most sciences. So when you're doing statistics for psychology or something like that, what you're doing is you're saying, here's the standards my discipline imposes for inferring a general claim from some observed regularity. So in my discipline, when you observe some regularity and you have a sample that's of a certain size and the regularity is, this has this strength, then you're allowed to generalize and say that regularity holds across a wider population. Whenever you do something like that, you're doing inductive inference. You also do inductive inference when you, for example, without checking to see if the classroom meeting location has changed, show up at the same classroom that you showed up at last week and the week before and the week before. What you're saying is, in my experience, classrooms don't ordinarily change their location mid-semester, so this one probably hasn't either. That's inductive inference. You're looking at some past regularity or some past regularity and using that to generalize to predict the future. There's a presupposition here, which is that things will continue to be as they have been before, or there's maybe a better way to put the presupposition, which is this: things unobserved resemble things observed. So things that I haven't observed yet resemble things I have observed already. That's sometimes true, but it's not always true. So sometimes you'll get burned by induction. You'll show up to class in the same room that it's always been in, only to discover a note on the door that says, for some reason or other, the class has been moved to another location. Statistics, as I said, is often a way to formalize inductive reasoning and to institute disciplinary conventions to set standards for inductive inference. Now comes deductive inference. Incidentally, I should mention, this is the way philosophers use these terms, but in a lot of ordinary language, the terms have different uses. So when people talk about deduction in ordinary language, typically they mean abductive inference. Sometimes they mean inductive inference. But it's worth sort of marking in your mind, we're using deductive in kind of a technical way. And here's the technical way. In a deductive argument, the premises of the argument are reasons for the conclusion, and the conclusion follows by proof from the premises. That is, The argument is such that if the premises are true, the conclusion is guaranteed. Whereas in an abductive argument, even if you having a virus best explains the evidence in front of us, you might not have a virus. It might have been food poisoning, it might be psychosomatic, there's other possibilities. Similarly, in an inductive inference, even if your classrooms have never changed location before, it might happen this time. So even if you do a good job in performing abductive and inductive inferences, your premises are true, your conclusion could still be wrong. But a deductive inference is defined just as those inferences that are such that if the premises are true, the conclusion must be true. And there's a presupposition here as well, which is that there are inferential rules. There are ways of moving from premises to conclusion that are exceptionless, that are perfect. So that raises the question, what are these inferential rules? Well, first up, the rules are supposed to be self-evident. That is, the rules are supposed to be so obvious that no rational person could doubt them. Candidate rules include the following. No claim is both true and false. Every claim is either true or false, and every claim implies itself. Now, it's important to note we're assuming constancy of meaning. So when I say no claim is both true and false, let's consider a particular claim. I'm holding a pencil right now, and it's yellow. So I say this pencil is yellow. Well, if I use the sentence this pencil is yellow to refer to the pencil in my hand right now at one time, and then at another time use the sentence this pencil is yellow to refer to an entirely different pencil, which is red, I haven't contradicted myself because I used this in this pencil is yellow and this in this pencil is yellow in the two instances to refer to different pencils. Okay, so here are candidates. No claim is both true and false. Every claim is either true or false, and every claim implies itself. Now, it's important to note that when you assert these rules, you're assuming constancy of meaning. So when I say no claim is both true and false, what I mean is no claim interpreted in a single way is both true and false. So consider an example. I'm holding a pencil right now, and the pencil is yellow. So I'll say the sentence, the pencil is yellow. That claim is true. Well, that claim can't also be false, but the very same sentence, this pencil is yellow, could be false because I could utter it about a different pencil. So if I'm holding a red pencil and I utter this pencil is yellow, then it's false. But that isn't violating this rule because this rule assumes constancy of meaning. So if I say this pencil is yellow is true, in order to show that it's also false, you'd have to show that the very same utterance of this pencil is yellow is false. But of course, that can't be the case. If this pencil is yellow is true, then it's true full stop. It's not also false. Okay. No claim is either. What I want you to see mostly is that these are pretty plausible claims, right? No claim is both true and false. It just can't be the case that the pencil is yellow and that it's also not yellow. The second claim is also plausible. It seems implausible that there's some nether region between truth and falsity. Either the pencil's yellow or it's not yellow. It's not somehow in between. Now, it may be a shade such that you're not confident that it's yellow, but your confidence has nothing to do with its actual color. Your confidence is a fact about you. It's a fact about your psychological state. It's not a fact about the pencil itself. Finally, every claim implies itself. That just means if it's true that this pencil is yellow, then it's true that this pencil is yellow. Those are all candidate starting points for deductive logic, and you can use them to build up all of the inferential rules that are standardly part of deductive logic. Now, these rules are formal, and it's important to notice what that means. What that means is the form of the rule itself determines that it's a good rule. The content of the propositions at issue aren't relevant to whether the rule is good or not. So let me give you two examples that illustrate this point. I should say, let me give you a contrast between two examples, and the contrast illustrates this point. If I say, if Iowa State University is a university, then it has a math department. Iowa State University is a university, therefore Iowa State University has a math department. I've just made a deductive argument. Now, maybe you think the premises of that argument are true, maybe you think the premises are false. You can object to the premises. You might say, look, I don't think Iowa State does have a math department. Or you might say, just because it's a university doesn't mean it has a math department. Those are both possible claims that you could make. But what makes the argument deductive is not whether the premises are true or false. What makes it deductive is conditional. It's if the premises are true, then the conclusion must be true. So if those true premises are true, then the conclusion must be true. Hence, the argument is deductive. In that respect, deductive logic, deductive reasoning, deductive arguments, it's like mathematics. So when you add 1 and 1, you get 2, and it doesn't matter what you're adding. If you're adding chickens, 1 chicken plus 1 chicken is 2 chickens. If you're adding pencils, 1 pencil plus 1 pencil is 2 pencils. It's irrelevant what you're adding. 1 plus 1 is always 2. Similarly, you can do an abstract characterization of the form of any deductive argument, and any argument with that form is logically good. It may have false premises and so not be a great argument, just like somebody who says 1 plus 1 chicken equals 2 chickens may not have 1 chicken. And so you can't infer that they have 2 chickens. But if they have 1 and they add another 1, then they get 2. That is clear. Similarly, if Iowa State is a university, and if any university has a math department, then Iowa State has a math department. Any argument with that form is a good argument. So the form, not the content of the premises and conclusion, determines the quality of the inference. So compare, as I just did, 1 chicken plus 1 chicken equals 2 chickens, 1 cat plus 1 cat equals 2 cats. There, the form, not the truth of having a cat or a chicken, determines the quality of, it determines whether the equation is true. Okay. Rejecting arguments. Now, arguments can go wrong in either or both of 2 ways. They can have a false premise or a bad inference. So let's look at this argument here. If that was 5 minutes, then you wouldn't be arguing. You are arguing, therefore that wasn't 5 minutes. You might say one of these premises is false. You might say, it's not true that if that was 5 minutes, then I wouldn't be arguing. After all, I could be arguing in my free time. That's what one of the interlocutors in that video says if you watch the video. Or you might say, look, it's not true that I am arguing. I'm just saying irrelevant things. Maybe I'm just contradicting, and that's not arguing. Another possibility is that there's a bad inference. And if there's a bad inference, you can say, look, I think the premises are true, or at least I'm not going to consider whether they're true or false. But I think the conclusion doesn't follow from the premises. So in that case, you're rejecting the therefore bit of the argument, not the premises. Now, in this particular argument, this argument is deductive. It works. That is, if this premise is true and this premise is true, this conclusion must be true. And we'll talk about why that is later on. You don't need to see that right now. So saying this is a bad inference isn't actually an option in this case because it's not a bad inference. Or at least you'd be wrong if you said it's a bad inference. Now, I'm going to introduce some jargon now, some technical terminology that's useful for thinking about the world, thinking about reasoning, keeping track of what you're up to when you're reasoning and when other people are reasoning. When an argument goes wrong in either of the ways I just described, we say the conclusion does not follow from the premises. That doesn't mean the conclusion is false. It just means the argument you just made doesn't give you reason to believe the conclusion. So if you accept the conclusion, it has to be for other reasons. Okay. What is logic? Logic identifies the rules or guidelines that govern inferences. Typically in philosophy, we use logic to address only the rules and guidelines that govern deductive inferences. And that's because deduction is very well understood and because it's an incredibly useful tool for representing your reasoning. Even if, at the end of the day, your reasoning is inductive or abductive, you can represent it in the format we just described, where you use the deductive rules of inference to say, given this bit of evidence and that bit of evidence, we get this conclusion. And it makes it very clear how your argument works. Okay. So when I talk about people's arguments, I'll typically frame them as deductive arguments, not always, but typically, and I'm going to ask you to do the same. Later in the semester, when you do your 2 short writing assignments, and sometimes on exams, I'll require that you frame arguments as deductive arguments. Okay, we're going to stop this video there, and in the next video, we'll talk about some properties of arguments that are important.